Now we are going to start with entity relationship model. Entity relationship model. When we start with the entity relationship model, again the first thing that we need to consider is the entity. So entity, already I have explained you the definition. Entity is a thing or object in the real world that is distinguishable from all other objects. For example, every person is an entity, every company, every university, every institute, everything is an entity which is distinguishable. So, entity, it is considered as a single entity. When, and this entity has some characteristics, correct? Each entity has characteristics and that are known as attributes. So entity has attributes or its own characteristics. For example, when we consider a person, name, address, phone number, etc. When we consider the student, ID, name, department name, its credits, address, phone number, etc. When we consider department, so every course has some attributes such as course ID, course name. For example, course ID we can say UCSE 0503, course name database engineering. There are 3 credits, etc. Every department has some attributes, a department name, department address, or the location where it is located, its budget, etc. So every entity has some characteristics. We call it as a attributes. Next, an entity set. Again, one important word. Entity set is a set of entities of the same type. Entity set is a set of entities of the same type that share the same properties or the attributes. That share the same properties or attributes. Means what? See here. Set of all persons. Try to understand what is entity and what is entity set. Both are different concepts. Now, when we consider this instructor entity. So, instructor, this is first entity. This is first entity 1 in this one. This is second entity. This is third entity. This is sixth entity. And all these entities together, set of all entities that possess have the same attributes or same characteristics. This entity has ID and instructor name. This entity has also ID and instructor name. This entity is also ID and instructor name. So all these 6 entities are same characteristics, have same attributes. These are grouped together and this is known as instructor entity set. What it is known as? Instructor entity set. So entity set is the group or set of entities of the same type that share the same properties or same attributes. In the same way, this is the first student entity. This is the second student entity. This is the 7th student entity. And all these entities have same properties and that's why this is a student entity set. So we are going to word after this as an entity set everywhere. Means that instructor table becomes the instructor entity set. Student is the student entity set. All students have the same attributes. Okay. Now the next relationship. A relationship is an association among several entities. A relationship is an association among several entities. Means when we consider the student entity and the instructor entity. And these two are associated with each other through a relation which is advisor. Which is advisor relation. So that is shown here. Example, this Peltier, this student, the advisor of this student is Einstein. Who is the advisor of this student? It is Einstein. So that is the relation between this student entity and this instructor entity. Now, as a relationship, this value is represented like this: 445532222. It is the ID of the student and this is the ID of the instructor. So these together is a relationship. Now all these same set of relationship set is known as relationship set. The set of relationships of the same type is known as relationship set. So in this way, how we mathematically represent a relationship set? E1, E2, En. What is this E1, E2, En? What is these two values? This is the attribute from first entity set and this is the attribute of second entity. Now what is this attribute? Normally it is a primary key. Afterwards we are going to see in detail how these values comes. What is this value? Whether we have to consider this name or whether we have to consider these IDs. So whatever the primary keys, these are considered as the values in the relationship set. So in this way, mathematically it is represented as E1, E2, En, where E1 belongs to the first entity set, E2 belongs to the second, En belongs to the third entity set. So in this way, we can represent a relation R. So the association between these entity sets is referred to as a participation. Means what? The entity sets E1, E2 to En participate in the relationship set R. The entity sets E1, E2 to En participate it in the relationship set R. So in our example, I can write a statement like this. The entity sets student and instructor participated in relationship set advisor. So in this way we can say that the entity sets participated in that relationship set. So in this example, the entity sets student and the instructor participated in the relationship set advisor. So the word used here, participation. That is shown here with this simple diagram also. This instructor is the advisor of this student. So as I told you that the advisor relation, how it is represent, or I draw it as a table only so that you can understand it more. SID and IID. Why it is taken? As these are the primary keys. What is mean by key? Why it is a primary key, and all these concepts we are going to see in the next unit lecture. So here only consider this SID and IID is considered. So how we represent the advisor relation? This click with instructor ID. I write here IID and SID. So instructor ID 76766. It is the advisor of the student Tanaka with SID 988. Then these cards with ID 4565. Now this is the advisor of two students, Shankar and Jang. So 1, 2, 3, 4, 5 for Shankar and 4, 5, 5, 6, 5 this instructor. Again the advisor of Jang 00128. Now this Srinivasan with ID 10101, advisor of Brown with 76543. So in this way the relationship set is represented. So in this way the relationship set advisor is represented, which is the association between the instructor and the student, which is the association between the instructor and the student. So same. Now the relationship set has, it is possible that a relationship set has its own descriptive attributes. A relationship may have its own attributes, and these attributes are known as descriptive attributes of that relationship set. For example, it is shown here. The advisor relation is there in between the instructor and student, and we can give an descriptive attribute for it as the date on which that instructor becomes the advisor of the student. In our example, we can say mentor. The instructor becomes the mentor of that student. Simple example. Instead of advisor, if we consider mentor in our case. So the date on which the instructor becomes the advisor of the student, that also we can add. Then how that relation is represent? Advisor, then I will write it here. The advisor relation, then it is represent, instead of two attributes, there is a third attribute which is its own attribute. Descriptive attributes means here IID, SID along with date. So first creek, how it is represented, then 766766. Then it is the advisor of Tanaka 9888, and what, which date it becomes the advisor? He becomes the advisor of Tanaka on 3 May 2008. Similarly, cards 45565 becomes the advisor of Shankar 12345 on 10 June 2007. Means here a new attribute is added, that is called descriptive attribute of that particular relation. Very few relation has their own attributes, rarely. Now the degree of relationship set. Till now we have seen there are two entity sets participate in the relation. That is known as binary relationship or binary participation. So binary relationship involve two entity sets. So what is its degree? 2. Most relationship sets are always binary in the database system. More than two entity sets are very rare. Relationship between more than two entity sets is very rare. Most of the relationship sets are binary. But one example here for ternary relation. So as it's a ternary relation, how many entities are participate here? As it is a name ternary, 3 entity sets participate in that relationship set. One example is given here. Student work on research project under the guidance of an instructor. So, for example, I write here, simple diagram I draw here. Student, instructor, and that student work on some project as we are working in PBL under the guidance of this instructor. So I can say here project guide is the relation. So it is a relation between these three. This student perform a project under the guidance of this instructor. Means it requires the information of all these three, but these all are associated together through a single relation, that is project guide. That is ternary relationship set. So what is the degree of this? The degree of this project guide relationship set is 3. So the number of entity set that participate in the relationship set is degree of that relationship set. Means if 4 relations are participate, 4 entity sets are participate in a relationship set, then the degree of that relationship set is 4. The number of entity set, whatever participate in that relationship set. That is degree. Now the attribute. So attribute, each attribute, so every entity has some characteristics, correct? And that characteristics we call attribute. Means student has ID, name, department name, etc. Credits. These are the attributes of the student. Say instructor, course, department, section. Every entity set has its own attributes. That is the characteristics. Now see, there is one important concept related to the attribute, that is domain. So each attribute, there is a set of permitted values for each attribute. There is a set of permitted values for each attribute that we call domain of that attribute. There is a set of permitted values for each attribute that we call domain of that attribute. What is the domain? For example, if we consider student ID, it is a character of length 8. So what is the domain of that attribute? It is a character of length 8, means the set of permitted values, only character we can add of size 8, not more than 8. If I say salary is of integer, so the set of permitted value is integer value only. No character values are allowed for salary. That is known as domain. What is the domain of IID? Character of size 8. What is the domain of salary? Integer. In this way, another example of domain is the semester. Semester is of character type, but it may be possible that there are some fixed values for the semester. In our case, we say one semester 1, 2, 3, 4, 5, 6, 7, 8. So whenever we enter the value for the semester, we need to enter only one of these 8 values. In our case, semester 1, 2, 3, 4, 5, 6, 7, 8. So these are the set of permitted values for semester, and this is called the domain of that semester attribute. So it is known as domain of that attribute. So in the example here, it is fall, winter. In outside India, the actually such kind of semester names are there: fall, winter, spring, and summer. In our case, first semester, second semester. So domain permitted values for the semester attribute is 1 to 8. And how to apply this domain constraint? We can apply while we create the table. Again, with the help of query, we can apply this domain constraint. Means that permitted values are only allowed for that particular attribute. Now, the types of attributes we are going to see here. The first type is the simple and composite attributes. Simple and composite attributes. So, simple attribute is an attribute that we cannot divide, into subparts. That is simple attributes. And composite attribute, an attribute that we can divide into subparts. So very simple definition of simple and composite attribute. Attribute that we cannot divide is known as simple attribute, and the attribute that can be divided into subparts is known as composite attribute. Okay. So the composite attribute can divide it into subparts. The examples are given here. The name. Name is a composite attribute which can divide it into 3 components: first name, middle name, and last name. component attribute. It is divided into these three components. Address is a composite attribute which can divide it into street, city, state and postal code. Again, street is a composite attribute which can divide it into three components: street number, street name and apartment number. That is simple and composite attributes. Types of attributes these are. Second type of attribute is single valued and multi-valued attributes. As its name, single valued and multi-valued. So very easy to define. Single valued is an attribute which has a single value only. So the example is salary. It is always a single value attribute. ID, it is always a single value attribute. Name, it is always a single value attribute. Now multi-valued, as its multi-valued means the attributes which can take more than one value, which can take more than one value, or which we can assign multiple values, which we can assign multiple values. Phone number is a multi-valued attribute. It may be possible that a particular student, instructor, employee may have multiple phone numbers. Another dependent name for an employee. Suppose the employee table is there and one dependent name attribute is there. So dependent name, multiple dependent names are possible. One employee has its parents, wife, children, etc. Then email ID, correct. Email ID also multi-valued attribute. So this is another type of attribute, single valued attribute and multi-valued attribute. In a bank, multiple accounts, it is possible. Now, derived attribute. Derived attribute is an attribute that can be derived from other base attribute. It is derived from base attribute. For example, suppose age of the person we want to calculate. So it is possible that we can calculate it from date of birth. If date of birth is available in the same database, from the date of birth and current date, it is easy to calculate the age of the person. And that's why it is known as derived attribute. The attribute which is derived from the base attribute date of birth. So date of birth is a base attribute and age is a derived attribute. Now the derived attribute is normally not saved in the database. It is not saved in the database. It is created whenever required. It is generated, calculated whenever required. It is not saved in the database. Why? If we save the age of a person in the database, then in the next day it is changed. So whenever required, it is calculated. It is not saved in the database. That is about the derived attribute. Next, null attribute. The null attribute is either missing or not known. Null attribute is either missing or not known. So when an entity does not have a value for it, then the null value is used. For example, it may be not applicable if the value does not exist. But if the value is exist but it is missing or not null, in that case also null value is entered. For example, when we consider the address table is there with street number, then street name, apartment name, etc. Now for a particular address, for particular employee address, ID of that employee or instructor 101, street number is available. Street number suppose S1000, but the name is not there. There are three different possibilities. Not applicable means for that street name is not there, available, does not exist. Either it is missing or not known. So in that case, it is stored as a null value. It is stored as a null value. In the second employee, it may be possible that street name is available, but the street number is not available. Either it is not applicable, it is missing or not null. Then in that case, street number becomes null. That is null attribute. Some of the attributes are never null, such as the primary key attribute ID, then the name of the student or the instructor. Such kind of attributes we can't say null. There should be value for that attribute, but this street number, street name, apartment name, all these kind of attributes may be null. All other attributes need to be some or assigned to be some value, which are not allowed as a null attribute. Now we are going to see what are the constraints on the ER model. So there are two types of constraints on the ER model. So when we draw any design of the database, first we need to start with the ER diagram or ER model. So while we construct this ER model, there are some constraints on this model, how to create or how to design the ER model. And these two constraints we are going to see here. So any ER enterprise schema have certain type of constraint to which the contents of the database must conform. There are two types of constraint. First is the mapping cardinality and second one is the participation constraint. So first we see in detail for mapping cardinality and then participation constraint. So mapping cardinality. So as its name, mapping, or we call it as a cardinality ratio. So cardinality ratio or mapping cardinality express the number of entities to which another entities can associate via a relationship set. So the number of entities to which another entity can associate via a relationship set. Means suppose we consider one entity as a student, second entity as an instructor, and in between there is a relationship set, that is advisor. Now mapping cardinality express how many number of student entities associated with how many number of instructor entities via advisor relation. That is cardinality ratio. So it is most useful for describing the binary relation. For binary relationship set, the mapping cardinalities as four types: one to one, one to many, many to one, and many to many. Now see in these four types with detail with example. It's a definition. So one to one as shown here in this diagram. So one to one means an entity in A and entity in A associated with at most one entity in B. An entity in A associated with at most one entity in B, and entity in B associated with at most one entity in A. That is 1 to 1. An entity in A associated with at most one entity in B, and entity in B associated with at most one entity in A. Suppose we consider A as an instructor relationship, instructor entity set, and B as student entity set. So this definition 1 to 1 means what? And one instructor associated with at most one student through the advisor relationship set. One instructor associated with at most one student through the advisor relationship set. And one student associated with only one instructor, that is 1 to 1. So this mapping cardinality is very important because while we draw the ER diagram, it is required. While we decide the keys of the relationship set 1 to 1, and this mapping cardinality is very important. When we decide the primary key of the relationship set, again these concepts are very important. So mapping cardinality, you need to understand what is actually it means. So the first one is 1 to 1. Second one is 1 to many. 1 to many means an entity in A associated with, you can observe, any number of entities in B. Any number means 0 to any. Any number means 0 to any. So an entity in A associated with any number of entities in B. An entity in B associated with one entity in A. An entity in B associated with at most one entity in A. Again, I am repeating, an entity in A associated with any number of entities in B. An entity in A associated with any number of entities in B. Any number means 0 to any. An entity in B associated with at most one entity in A. Again, if we consider the same instructor to student association through the advisor relation, then what is the meaning of this statement? One instructor associated with any number of students. One instructor associated with any number of students, but one student associated with at most one instructor. But one student associated with at most one instructor. So one simple example, that is our mentoring system, in which one instructor, one faculty has many number of students, 0 to any number of students, and one student associated with only one instructor as a mentor. That is the simple example of one to many. So these definitions are given here. Now the next one, many to one. So many to one, as its a definition, an entity in A associated with at most one entity in B. An entity in A associated with an entity in A associated with at most one entity in B. An entity in B associated with any number of entities in A. Any number against from 0 to any number. Any number means 0 to n, any number of entities. An entity in A associated with at most one entity in B. An entity in B associated with any number of entities in A. Again, instructors to student, if we consider the same example, instructor is our first entity and student is our second entity. So the meaning of this statement is that one instructor associated with at most one student, but one student associated with any number of instructor. One student associated with any number of instructor. And the last one is many to many. Many to many means an instructor or an entity in A associated with any number of entities in B. An entity in B associated with any number of entities in A. An entity in A associated with any number of entities in B. An entity in B associated with any number of entities in A. That is many to many. So our course instructor student, the regular example, one instructor associated with many students. I am associated with all of you, 80 students. Correct? One to many, or we can say one instructor associated with many students. And you people are also associated with multiple instructors. There are 5 to 6 course teachers are there. So one student associated with multiple instructor through the advisor relation. So it is many to many. The definitions are here. So always remember that many means 0 to any number. 0 is also possible. Participation constraint. Participation of the entity set in a relationship set. So as already in the last lecture I told that if there are n number of entities participate in the relation E1, E2 to En, then we form the relationship set with the help of that entity sets that participate in that relation, or we call participation of that entity set in that relationship set. If n number of entities are there. So there two types of participations are there: total participation and partial participation. Total participation means what? As its name, every entity in the entity set participate in at least every entity in the entity set participate in at least one relationship in the relationship set. Every entity in the entity set participate in at least one entity set in the through that relationship set. So participation of student, again the same example, if we consider the instructor and student to the advisor relation. So participation of the student in advisor is total. Why? In our case of mentoring, you observe that every student the mentor is assigned. Every student the mentor is assigned, means the participation of the student is total. Why? Every student is associated with at least one mentor. Every student is associated with at least one advisor as an instructor. So that's why it is known as a total participation. Every entity, every student entity participates through the advisor relationship. Now partial participation. If only some of the entities in E participate in the relationship set R, then we call it as a partial participation. If only some of the entities in E participate in any relation R in the relationship set, then it is partial. Some of the entities. For example, participation of instructor in the advisor is partial. It is not necessary that every instructor assigns some student. For example, if the head of the department person is there, to them the mentee students are normally not assigned. If a new faculty or the new instructor entered, then in that case, that faculty also no student is assigned to that faculty. So in that case, the participation of that instructor in the advisor is partial. Why? Because some of the faculties are only participated, some of the faculties are, for some of the instructors are not participate in the advisor relation. That is total participation and partial participation, and these concepts we require again in the normalization.